Okay, in this video we are going to continue with our Chapter 6 exercises, and we're going to pick up with exercise number 6. And this one reads as follows. It says, write an application that shows the sum of 1 to n for every n from 1 to 50. That is, the program displays 1, the sum of 1 alone, 3, the sum of 1 and 2, 6, the sum of 1, 2, 3, etc., and so on. So this is a common little programming exercise that also teaches you a little something about math. But one of the keys to making sure that you're doing this correctly is to make sure that you understand the sequence. And by virtue of understanding the sequence, you should know what the answers are. There's a number of different ways to do it. One is what they've shown here. So I'm actually going to bring up my little text file here and just use it as a kind of a scratch pad. And I'm going to keep that in view at the same time. So 1 would be the first one, right? And then when we add 1 and 2, it becomes 3. When we add 1, 2, 3, it becomes 10. When we have 1, 2, 3, 4, well, that becomes 10. I apologize. So we're missing a number in there. So it goes 6, 10. So what's the next number then? What's 1 plus 2 plus 3 plus 4 plus 5? 15. Okay, now I happen to have my projector on. All right, so 1 plus 2 plus 3 plus 4 plus 5 is 15. Then we're going to add 6 to it, right? So the next number is going to be 21. And then we're going to add 7 to it, so the next one's going to be 28. Then we add 8, and it's 36. And then 10. All right. But actually, we only need to go up to 50, so we don't have to go quite that far. But that's what we're looking for. So we need to write an equation that's going to do that and put it in a loop, right? Because every time we do it, it's going to add to it. So that's going to be kind of our model outputs, just so we know what we're looking for. And then whenever you're doing something like this, you need to be able to verify it. So you kind of actually have to do the work beforehand, whether it's manually or with a calculator or whatever. There's a number of different ways you can do it, but that's really up to you how you proceed. Let me actually go back to the text here, and let's grab the name, every sum. And this time, let's go ahead and start with a fresh file. And we'll form our public class named every sum. Opening and closing curlies. Let's get our main method in here. I don't even know if we need that much space, honestly. All right, but now let's try to reason this through. This is a chapter about loops, so we know we're going to be using some sort of a loop. Now the question is which type, and to me this one clearly points out a way to do it, but you know, I'm a math guy, so of course it does. But whatever we do need to keep track of the number that we're going to output, because really when we're doing this output, every time a number comes out, that's the sum of all the previous numbers, right? So I'm just going to put together a variable here called sum. And because I'm going to be doing math with it, I am going to preset it to 0 just so it's clear. Then we're also going to need a number that we're going to count with. Now how you do that, that's up to you. I could just set up an int called n like they do in the problem. That's one thing I could do. In fact, let's just do it that way. Now, let's think about the procedure for putting the number on the screen. So if I start with 0, right, and then I'm going to add to it the current value of the last number I counted. Now, let me explain. Maybe my words aren't just clear as what my thoughts are. All right. I start with 0 because if I have the sum of 1 alone, really it's kind of like adding 1 plus 0. You can kind of think of it that way. Okay. So if I'm counting, each time I'm counting up, I'm like 1, 2, 3, 4. So I'm going to have a loop that counts up by 1. Okay? So think of how we did this, right? Once I had the sum already set, the next sum is the next counting number plus the previous sum. So when I got to 10 and I knew the next number that I was adding was 5, it was pretty easy to add the 5 and then add the 6 and then add the 7. And you can see the pattern there. It's actually a pretty simple little pattern. All right, so for me the best approach is using a for loop. And that's actually kind of the intention here. And we're going to start out our loop at 1. So I'm going to say n equals 1, and that's the number that we're counting by. That's our counter for the loop. And we preset that counter inside the loop definition. And then we're going to say, while that number, and now I'm thinking to myself, is that the right logic? Well, the number is less than 50. Or should be less than or equal to 50. That's my current thought. Well, actually, let's read the instructions again. I just want to make sure we have it clear. Write an application that shows the sum of 1 to n for every n from 1 to 50. So we are going up to 50, so that to me that says include 50. Every time we go through the loop, we're going to increment our counter. All right, I am going to put in curly brackets here. And let's figure out what we're going to do. Well, the sum starts at 0. In order for me to output the sum, I need to display what the sum is. What the sum is going to depend on what we put into it. If I preset the sum to 0, but I want it to display 1, I need to add the sum, remember that's 0 right now, plus whatever n is. So the first time through, we're coming in with 0, n is 1. Is n less than 50? Absolutely. And I'm just thinking I might have this incorrect, but well, let's figure it out. We'll see if that's what's intended. So sum is 0. We add 1 to 0. Sum becomes 1. And then we should put that on the screen. Let's do system out. And we can do print line here. That's fine. Actually, let's do a system out print. And we'll output the sum and a space. All right. And if my brain is working correctly here, I think that might be all we need to do, which almost seems way too simple, but these exercises are not designed to be hard. But I'm going to check the instructions again because you can read them a few different ways. So okay, so I think I'm reading it correctly. To me, it says that we are going to do this 50 times, basically. So this prediction is correct, but we are going to carry it on. So do we have 55, 66, 78? What would come next? Plus 13. Well, here, you want to see a really easy way to do this? I use my handy little friend Excel here. And basically what I'm going to do is I'm just going to type in the sequence of numbers, and Excel's got a nice little feature in it. So if I do 1, 2, 3, Excel's pretty clever and picks up the pattern, and I can just keep going here all the way down to 50, right? And then it's got a nice little feature also where if you look, when I select two cells, notice at the very bottom of the screen, it gives me the sum. Right down here. I know it's hard to see for you people in class, but 1 plus 2 is certainly 3. If I keep expanding at the selection, that's 6, 10, 15, and those numbers should look familiar. But then, if you keep going, you can see the value incrementing up. So I could actually write a formula in Excel to do that calculation for me. But what I'm going to do is I'm just going to go all the way up to 50, and really the ending number here should be 1,275. Okay, so that's what we're looking for as an answer. Now I set this up to do a print instead of a print line, and now I'm having second thoughts about that, so I'm going to do print line, so it will spit out 50 lines of output. But let's see if my logic is correct. It should be fine, and I do want to point out, whenever you see this type of thing going on, where it equals sum plus 1, sum plus 1 is not correct now that I'm thinking about it. Really, every time 1 or n increments, it should really be sum plus n. Okay, that makes sense. And since sum is already part of the equation, I can just replace this with plus equals. All right, I think that's it. It almost seems too simple, but sometimes that's how it goes. All right, I'm going to go ahead and compile. No problems. And let's run it, and it looks like we were successful. Right? It ended at 1275 like I predicted, or how Excel predicted. These numbers here are all the same ones we predicted. So I'm going to make the assumption that all the rest in between are fine. All right, so that's it for that one. That was a pretty simple one. So hopefully that one didn't stump you. If it did stump you in any way, it is basically because maybe the problem explanation wasn't as clear as it could be. For those of you that have taken a lot of math, you'll recognize this type of structure. It's a certain type of sequence, and it can be expressed in a calculus format. Pretty much they do it just like this, but they have a special notation for it where you use the letter sigma, and you would type in this thing, and that whole thing would turn out to be 1275. But kind of a neat little way to do it with a computer program. All right. Our next problem now is exercise 8. So let's move on to exercise 8. And this one's more of a challenge of doing output and making it appear a certain way. And basically what we're doing here is we're going to run a loop, and each time we run the loop, we're going to add an additional space in front of the x. I mean, so obviously you could do a system out and then just add a space and do 5 statements. That's not the point here. The point is that each time you run through the loop, you're adding a space before the x prints out. So let's go ahead and take a quick pause. Okay, let's jump over to JGrasp and see if we can figure out a way to make this happen. I should grab that name. They just want me to call it diagonal. So let's just go ahead. I'm going to use this structure here, so I'm going to just call it diagonal. And I'll do a save as, so it picks up the file name. And I'm just going to count on the fact that we probably won't need any of these variables. Or if we do, it won't be in the fashion that we want. Now, the trick to this one is, how do we get it to do this? If we were just going to output an x, right? Let's forget about the spaces for right now, because that's going to be the challenging part. How would you output 5 x's in a loop? Well, I'm hoping that that's going to be really easy for you to think about. Basically, what I would do is I would set up, well, I can use the letter n, that's fine. I would set up a loop, and I would count from 1 to 5, or if I want, I could do 0 to 4, whatever it might be. But here's my thinking. I'm going to start counting with 0, because the first time we go through, we have no spaces. The second time we go through, we have 1 space. So that's the reason I would start counting with 0, because that just, it makes sense to me. So I'm going to actually, we might do a system out, so I'll leave that there. I don't know if we're going to have a sum, but I think we are going to have an x, right? So that's going to be in there somehow. And if we start counting at 0, and how many times are we going to go through the loop? 5. So while n is less than 5, or less than or equal to 5, what do you think it should be? Less than 5. Well, we'll see if that's right. And then we're also going to do an increment, and I'm going to be a little sneaky here, and this time I'm going to go plus plus n. And then I'm going to question you is, does it matter where we put the increment before? Does it make sense to put the increment before the n or after the n, or doesn't it matter? Well, I'm going to put it before, and then we'll test that, because I know some people have a little bit of confusion on that. All right. Do we need some? We don't need. Int we have right there, int n. Now it is important to note too, if you want, you can just say that right here. You can just declare the integer right inside the for loop if you didn't know that. Just like that. And so what I'm tempted to do right now is let's just go ahead and run this and see if at least this part's going to work. So go ahead and save it. I'm going to compile it. Now my expected output is it's going to start counting at 0, print an x, becomes 1, print an x, 2, 3, 4. That's already 5 of them. Now it's up to 5. It's not going to run. Remember, 0 to 4 is 5. And that should really do it. So I'm going to click run, and sure enough, I've got 5 x's. So that part's simple, right? Now we need to put a space in front of each one. So here's the question with that. How do I do that? Well, the one thing that you should think about is if I am going to output a space, well, I can do it a number of different ways. Well, for sure, I'm going to need to do something like this. So I'm probably going to have a statement just like this, but instead of with an X in it, is going to have a space in it, right? But if I do this, that's not going to give me the results I want. In fact, I want to do the X after I print the space, right? So I need to switch those two around. But the first time through, I don't want it to do a space. Okay, so the solution to this, if you haven't thought about it yet, is to have another loop. But this is what we call a nested loop. So this nested loop is going to be placed inside the original loop. I'm going to need a separate counter, and I'm going to preset this one also to 0. And then I'm going to, this is going to be the tricky part right here. I know for sure, I don't know what my logic's going to be here, so I'm just going to put a question mark in. But I do know that either way I'm going to do an increment at the end. And every time I go through that loop, I'm going to do a system out print line with a number of spaces. But the question is, how many spaces will print out each time? If it just keeps looping through, it's going to add only a certain number of spaces. So if I preset this, and this is why I have the question mark here, because think about, okay, we have 2 loops. If I start the outer loop, so first time through it's 0, right? So it's 0, and given the fact that it's 0, it'll come in here, and will this run or will it not? I don't know, because I haven't really set the criteria for it yet, but it will output an X. So my goal here is to figure out how to add that correct number of spaces prior to printing out that X. Now, maybe some of you have already figured it out, but one of the tricks is that whatever the number of rows it is that we have that we're doing, so that 5 that I've put in here, and maybe seeing is better than hearing. So the first time through is time 0. So instead of thinking of this as row 1, think of it as row 0. So row 0 has 0 spaces. Row 1 has 1 space, 2, 3, 4. Okay. So what might be helpful for you, and sometimes my brain works like this, so please keep that in mind. I might actually say, how many rows do we have? And I might preset the rows to 5. And that way when I come down here, instead of saying 5, I say rows. So now it makes sense to me. While n is less than the number of rows, then do this stuff inside the loop. All right, so in the same capacity, if m is equal to 0, what criteria do I use here? I will use the letter M. My guess is that it'll be less than what? I think that's a good guess, right? So while M is less than the number of rows, print out a space. And here's my thing now. Or is it? Okay, so think of what will happen the first time through. M is coming in as 0. The outer loop is 0. We already know the outer loop works, so we know this part works, and we know this part works. The first time we come in here, is this going to run? Yes. Okay, if you're wondering, yes, it is going to run. In fact, it's going to run just like the other one. So what this is going to do, in fact, let's not guess at what it's going to do. Let's take a look at what it's going to do. So I'm going to go ahead and compile this. Okay, now I'm going to run it. So what did it do? Oops, got so much junk in here. What it did, right, and I do have another error in here. So let me actually remove, I don't want to do a print line there. I actually want to do a print. So let's go ahead and run it again. And just in case you guys are wondering, whenever you click that run button, it does the compile, the save, compile, and run all in one step. So what it's doing here is it's adding 5 spaces before each X. So that's not right. We need it to add up each time. All right. So in other words, setting it to 5 is not the right thing to do. So what we might want to do is actually set up another variable, and I'm going to call it spaces, and I'm going to preset it to 0, and then change this inner loop to say spaces. So while M is less than spaces, so initially we come in and spaces is 0. Is 0 less than spaces? No, they're the same, so it would not print a space. But next time through the loop, we do want it to make a space, so what we do, after we output our X, is we are going to increment spaces by doing a plus plus. Okay, so now think about what happens. The first time through, spaces is 0 and M is 0, so this little loop will not run. The X will print out, then we add 1 to spaces, so when we come around for the second time, second iteration, M is still 0. Is 0 less than 1? Yes. We print the space, we increment the counter, M becomes 1. Is 1 less than 1? No, it pops out. So you see the logic there, hopefully? Hopefully. All right, so I'm going to go ahead and save, compile and run. And that's all it is. Now, of course, the trick there is figuring out that logic, because that's not necessarily straight ahead. And if it doesn't make sense to you, one of the fun things to do is to actually set up a little, even a little whiteboard or something, where you step through the loop and test it. All right? So let me just walk through it one more time, so hopefully for a little clarity. We have a number of rows, that's 5. We have a number of spaces we're starting with, that's 0. This outer loop, the one that holds everything, we set the counter at 0. We know that that counter is less than rows because we set it up that way. If it's not, if this condition is not true, loop will never run. So we have to make sure that at least initially it's true. So 0 is less than 5. So we go into our loop. Spaces is 0. Is 0 less than 0? No. Move on. I'll put an X, add one space, go back up to the loop. N is now 1 because of the plus plus. Is 1 less than 5? Yes, it is. We come to this loop. Is 0 less than 1? Yes. We output a space. It increments automatically. Is 1 less than 1? No. Move on. I'll put an X. So we printed one space and one X. Now we add a space, come back up. N is now 2. 2 is less than 5. We run the loop. M is now 2, right? Spaces is now 2. M starts at 0. Is 0 less than 2? Yes. I'll put a space. Increment. Is 1 less than 2? Yes. Space. Increment. Is 2 less than 2? No. Move on. Print an X. So that's the procedure there. Hopefully that description made a little more sense. If not, it's really a good practice to actually make a little table and just say, what's this, what's this, what's this, as you're going through, and just change the numbers one at a time until you get it. But that's actually a pretty simple little exercise in doing a loop inside of a loop. And that's all there is to it. Not a lot of code. It's more of a logic thing than it is a volume of code thing. This video will end here, and I'll start one more to complete things for the next exercise.